All right, taking a look at the problem 8-86. It's part of the in-class work. There's A through D, and we're trying to find the quadratic equation that comes from the solutions that are given to us. So in the classwork, there's actually 3 different ways that you can do this, and they're covered in problems 83, 84, and 85. I'm going to go over basically the ways from 84 and 85 because I've never really seen kids use problem 83 on any assessments as we move forward through the rest of the year. So I'm going to focus more on the ideas from 84 and 85, and I'll sort of reference those. I've also already posted some videos for 84 and 85, so if you have questions on that, you can go and look those up. I have those on Canvas already. So problem 86A, we have 3/4 and -5, and those are the solutions. Those are roots for the problem. What that means is that we have x equals 3/4 as one answer, and x equals -5 as another answer. So if I want to work backwards and think of what are my factors that gave me these as the roots. So our factors, when we do zero product property, we normally have x plus or minus some value here, b, and that's going to end up equaling 0, and then we move it over to the other side, and we solve for it. So that means I want to get both of these actually equal to 0. So if I would move that over to the other side, I would end up getting x minus 3/4 equals 0. Normally, we actually don't even see that. We would actually even multiply this whole thing by 4 and get 4x minus 3 equals 0, and that would be our factor that would give us 3/4 as a solution. So I'm going to go with on this one that 4x minus 3 is our factor. From the other one, I'm going to move the 5 over by adding 5, and I'm going to get x plus 5 equals 0. So both of these here, if I had 4x minus 3 and x plus 5 equals 0, that would give me these solutions here. Well, if I want to figure out the original quadratic that came from, I'm just going to get rid of this, and that's my y equals. And now I'm going to go through and just multiply that out. So what I'm going to do is use a generic rectangle. And 4x minus 3 and x plus 5. So I'm going to get 4x squared, negative 3x, 20x, and negative 15. Combine your like terms, and I'm going to get y equals 4x squared plus 17x minus 15. That will now be the quadratic that gave us these roots. Again, that's using the same style that they use in problem 84, the same method they use from problem 84 of the lesson. Problem B, I have the roots 3i and negative 3i. So I could do the same thing as I did on the last problem. I could say that I have x equals 3i and x equals negative 3i, which would give me x minus 3i equals 0, x plus 3i equals 0. These are my factors. Make my generic rectangle, multiply it out. But I'm going to switch up actually the method for this one, and then I'm also going to do the same method for C and D that was learned in problem 85. And that method's going to be, if I'm looking at either one of these, it doesn't matter which one. But if I think of getting rid of the I and working in the completed, as in like we're completing the square and working backwards, I'm going to square both sides of these equations. So now I have x squared equals 3i squared is the same thing as 3i times 3i, which is 9i squared, and I squared is -1, so this ends up equaling a -9. So now I have x squared equals -9. So x squared plus 9 equals 0. And I just replace the 0 here, and y equals x squared plus 9. I'm going to get the same solution if I use this other option here, because if I square both sides, I'm going to now have a negative 3i times a negative 3i, and negative 3 is still a positive 9i squared, which still gives me negative 9, so I'm still at the exact same spot here. Give me the exact same solution. So problem C is 5 plus 2i and 5 minus 2i. So if I wanted to go through and think of x equals 5 plus 2i, moving everything over to the other side, I'm going to have x minus 5 minus 2i equals 0. Same thing for this one. I have x minus 5 plus 2i equals 0. And these are my factors. So now I need to make a 3 by 3 generic rectangle. So that's the way of doing it from problem 84, that method. But instead, I really prefer the method here of 85, where I'm working backwards. So x equals 5 plus 2i, and again, I can pick either of them. So if I'm going to use completing the square method backwards, I would move that over to the other side. So I have x minus 5 equals 2i. Then I would square both sides. So I have x minus 5 squared equals, now when I square that, I'm going to get positive 4 times a negative 1, because I squared is negative 1. So I'll get a negative 4. I'm going to add the 4 to both sides, so I have x minus 5 quantity squared plus 4 equals 0. You can see this is our completed square, and I'm just kind of working the other direction. So if I would be solving this by completing the square, I would just be going up, and now I'm just going the other direction to go backwards. So now, if I want to write this, and normally when we do these, we're going to want you to write them in standard form. So all I need to do is square that. So I'm going to get x squared minus 10x plus 25 plus 4 equals y. So my final answer is x squared minus 10x plus 29. That is the quadratic that gives these two roots. And lastly, I'll do problem D. I'm going to do it the exact same as the one I just did. I suggest pausing it right now and trying it yourself. All right, so this one does not have an imaginary number, but it still can be done the same way. So I'm going to have x equals negative 3 plus the square root of 2. So moving the negative 3 over, I have x plus 3 equals the square root of 2. Square both sides. X plus 3 squared equals now positive 2. And moving that over, I have x plus 3 squared minus 2 equals 0. Again, that 0 is the same thing as my y value. I'm just going to expand this part right here. So I have y equals x squared plus 6x plus 9 minus 2. And then just combining those last two terms right there. X squared plus 6x plus 7. That is the quadratic that gives these solutions. Hope that helps.